Great. Hi everyone. I think we have a bit of an issue here without a clear, uh, clear agenda in terms of who is supposed to speak. Um, I guess the purpose of today's meeting was just to revisit the caps that we have before the final approval, and the agenda suggests that the cap authors would present them. And I think almost all the caps have been discussed before, besides cap 70. So maybe if Karen is here, Karen here, yeah, maybe you could talk about cap 70 because it's completely new, and then we could, I don't know, I guess quickly recap other caps and is there any questions concerning any of this?
Cool. Yeah, that sounds good. So I guess getting started with Cap 70. This one is a recent addition to Protocol 23, but it's fairly small and straightforward. And so essentially what this does is it introduces a couple of new network config settings that control some of the timing parameters around consensus. So essentially today, like during consensus, there's a couple of hard-coded values, such as the block of the ledger or the length of the ledger being 5 seconds, as well as some of the more nitty-gritty details on consensus as to like how long nodes wait for certain rounds, like timeouts between certain consensus rounds and things like this. And so essentially, this cap doesn't actually change anything, but it just allows us to change these values in the future. So for instance, today, Stellar Core, all the nodes are hard-coded to have a 5-second ledger time, but with this cap, it allows that to be dynamic and configurable. And so kind of the motivation behind this is that as we want to move towards higher throughput and lower block times, making large jumps is difficult. Going from 5-second blocks to 2.5-second blocks is very, very challenging. So the goal with this is to allow us to kind of make small incremental changes via SLPs, where to get to that goal of 2.5 seconds or whatever it may be, we start by just trimming off like 100 or 200 milliseconds at a time, and over time we'll get there. And so essentially this cap introduces all these new config settings, but the default values are the exact same values that are currently hard-coded into Core today. And so cap 70 will have no noticeable change when it's initially implemented, but just opens the door to have more configurability and hopefully tighter iteration cycles as we go to improve consensus and nomination timing in the future. Yeah, so I think it's pretty straightforward and probably not super controversial, but if anyone has any questions or wants to talk about it, feel free.
Yes, I have a small question, which I kind of already asked in the cap, but basically, is it possible, like, for example, for Soroban network settings, it is relatively easy to understand what every settings means. And, if you're, for example, increasing the per ledger limit for instruction, like 100x, it is kind of easy to spot that it's probably not going to work because we will take 100 times more time to close the ledger. So my question here is, how risky is this set of parameters? Like, is it possible to accidentally vote for an upgrade that breaks the network in an unintuitive way because we're kind of altering the consensus algorithm, which on its own is used to do everything on the network, such as upgrades. So unbreaking the network would be tricky. So how risky it is to break the network.
Yeah, so I do agree with you. These are pretty kind of low-level technical settings. I think kind of the reason it makes sense from a technical standpoint to be config settings is that these are things that we want to change often and kind of slowly over time to make small incremental progress, and all the nodes have to agree on them, so it makes sense to be a config setting. But they definitely are difficult to understand. And so I think as far as validation, pretty much the only tool that we have is supercluster in kind of simulating the network and seeing the effect these values will have. and they definitely have effects that are sometimes not super intuitive. And so I think what we might want to do is especially when we just launched these features, is to put tight bounds onto the acceptable values. So for instance, like if today the default value for ledger close timer is 500 or 5,000 milliseconds or 5 seconds, if you were to change that to 50 milliseconds, the network that bad things would happen, and the network would be very unstable. And so perhaps what we can do is, given that at least my thinking, the goal with this cap is to make small incremental improvements, we could have very tight bounds just at the implementation level. And so, say for instance, like in Protocol 23, we could say that the lower bound on the ledger close time is like 4 seconds, or maybe like 3.5, or like that. And so, worst case, if someone was to propose like a 50 millisecond change, it just wouldn't go through. And even like these lower bounds, I think these would be like kind of guesses at this point, because there's still lots of testing and validity checking that needs to be done on these values. But I think if you go from 5 seconds to 4 seconds, that might still cause some network instability. But I don't think you would break the network in the same way that you would if you went from 5 seconds to 50 milliseconds. And so would something like that, maybe some tighter bounds, alleviate some of your concerns, Dima?
Yeah, yeah, that makes sense. Yeah, I still feel it might be a bit scary, but yeah, I guess we can try to make sure that maybe one thing I thought of when you were talking is that maybe we could limit the upgrade not only in absolute sense but also in relative sense, that you cannot
Mm.
really use by more than X% the current value, something that um, so that we don't need to guess too hard. It just kind of enforces incrementality.
Yeah, that's a good idea. I mean, like relative values might have some potential issues. Like so, for instance, I think I like the limited bounds a little bit better than relative changes, because you might be in a scenario where for some reason the network is broken, either because you've changed limits in some way, or maybe that there's like some sort of like a thing that's external to these parameters that's gone wrong that also needs fixing. So I could see a possibility where, due to the network being in a bad state, it would be advantageous to make large changes to these values. Um, and so I don't know if the relative sort of safety measure is as safe as it sounds from like a disaster recovery standpoint. But I think limited bounds at the minimum would be good, and even for like the relative the relative limitations. The issue is that for some of these values, you can do damage going in both directions, right? So increasing nomination timeout may improve performance, um, but so what I mean by this is that these parameters, it's not that the network gets more unstable if you go one direction, and then less or and then more stable if you go the other. And so I think having relative bounds might be a little tricky.
I agree. Like having bounds in general is just absolute bounds is probably the way to go on this. Like I think we may want to have those be more like some sort of like config settings, because I could see like for as the goal of this is to understand it in like in the context of like we want eventually to move those in the on the public network, have like the same defaults, so that public network is like it would take basically many things to be overridden, so for a bad vote to be accepted, but in a other environment like testnet or a test cluster, maybe you want to actually see what happens if you set those things to like half a second or whatever. So yeah, so I think it's the type of thing that we should do. On the thing I wanted to add though to this cap is that yeah, it's only the first building block. I mean, or the first change, I think. I imagine that is needed to really move on the latency front, because I can see certain things like that are going to be impacted as if this runtime gets too small. Because today we have, for example, the a lot of things on the network that are tied to like these 5 seconds. So like the thing I can think of is we take snapshots every 64 ledgers, or how fast do we spill from one level to another. Those things maybe need to change as the block time goes down. And right now they are not configurable. Of course, changing the speed of spilling is a much more involved change than changing the runtime. But that's I think something that maybe we'll have to think about.
Yeah, and I think that's one of the things that makes like this as a config setting interesting, is that lowering the block time is bound to break something. I mean, we can test Stellar Core and simulation environments and stuff, and even if the actual like layer one doesn't break, downstream like something will break somewhere for sure. And so hopefully if you shave 100 milliseconds off the time, you have one thing breaking at a time in minor ways. Whereas if you went from like 5 seconds to 2.5, I'd imagine many things would break all at once, which would be sad.
Yeah, I have questions, but the only comment that I have is that again, this is a similar property of all the settings, but since there is no like protocol version bound attached, that means that network may run on different versions of the core software, which means that um, the plan of like doing an upgrade based on some minor release changes may not be necessarily sustainable, because it's kind of tricky to get everyone on the same version of the software. I guess this may like we can try to make it happen, but to imagine the like major changes this direction would still need to be tied to like major releases probably. So I'm not saying it
Yeah,
shouldn't be a config setting. It's just an observation that even though it's a config setting, we might not be able to change it too often.
yeah, and I think that's why I'm kind of in favor of like runtime bound limits. I think Nico might have been hinting at like having like a config setting that's like the actual value and then an additional config setting for the bound. But I think like to Dima's point, like a protocol 23 package, um, it should be known that like the 23.0 package probably can only run within like these timing envelopes. And so I think that might be what's interesting, is that even though technically it's a config setting, what we might do is that we can only even though the bounds are part of runtime, or they can even be part of the protocol at this point. And then like say the bound, like the lower bound is 4 seconds in P23, and then the lower bound in P24 could be like 3 seconds. And so you don't change the actual value on the P23 to P24 upgrade, but you change how low the value can be. And I think that might be the best way to kind of think about these settings. Is that there is the bounds can change as our latency envelopes gets better, but the actual value is dependent on the network config settings.
Yeah, and I guess to that point, like since bounds are a quotation, yeah. Actually, I'm not sure if we can make some notes to disagree on the upgrade validity. Maybe it would. Yeah. Anyways, that's not super important, but yeah, something to explore.
I don't think this really needs to be part of the protocol. I mean, I think this can be like a safety thing, where there's like a contract that the upper and lower bound are just constants in the C++ code, similar to how the upper and lower bounds for other config settings are. And there is just like a agreed upon contract that you change these bounds on protocol boundaries.
Yes. I suppose there's a question chat. So Billy runs the changes on the supercluster and then provides with level data input on any hardware or VM upgrades in a timely manner. I guess Karen can answer. Yeah.
Yeah, so I think I think the answer is yes. So we're doing lots of supercluster testing. And I think part of this work too is that I've been kind of running some one-off tests myself of late. And I'm not sure if the default values on mainnet today are actually the best values for the network as it exists. In particular, the 1 second nomination timeout value and the 1 second ballot nomination or ballot timeout value are kind of like hard coded magic constants that have been in core forever that we haven't really questioned. And so I think part of this, while not part of the actual cap itself, is after we've released 23, doing testing both in supercluster and in testnets and things like this, and finding out what the true value of these things should be. I don't think ledger close time. I think that one's pretty set 5 seconds. But for these other values, I think there probably is some experimentation to figure out what the actual correct value should be in Protocol 23. And then, of course, in future protocols, as things change, figuring out the correct values are there as well. I've ought to say, the intention is not to, I think to answer Lou's question more specifically, to not use these config parameters to like force hardware changes or like force validators to, upgrade to beefier EKS SKUs. I think that's a different conversation. So I think, yeah, we'll definitely test. And the goal is not to use these parameters to require you to, buy more expensive boxes.
Right. I guess if there are no more questions on this topic, we can make a quick roundup proposal. Caps this protocol. This is what this meeting is supposed to be about.
Yeah, and maybe can I suggest not spending a whole lot of time on each cap, and it's more like if there are caps that maybe had like some significant or some changes in the last last month, maybe we can briefly talk about that. But otherwise,
yeah, exactly. That was my plan. Basically, what I wanted to start with is quickly go over caps that haven't changed, and I guess only since the only action item that remains with them is just to approve them, I guess. So, in no particular order, cap 65 reusable module cache has been both finalized a while ago and also implemented and merged. No changes there. Then parallel, sorry, numbers. Okay, caps 62 and 66 about state archival and in-memory read resource recurrent are still in implementation progress, but there were no changes to the cap semantics as well. So they stay as they are. Cap Yep. Cap 63 parallelism friendly transaction scheduling. Again, no changes. Protocol part of the implementation work is done for the most part. The actual parallel execution is work in progress, but again, no substantial changes there. Caps Cap 70 has just been discussed. Cap 69 new host functions hasn't been implemented, but there were no new suggestions there. And what remains are Cap 68 and 67. And I guess for Cap 68, there weren't any changes themselves, as it's a cap about host function for getting executable for a contract address. But I know Lee here. Lee might not be here. Lee had some concerns about the necessity of this function, and hope we could maybe work it out during this meeting, but yeah, since Lee doesn't seem to be here, I guess we'll take this offline. But in any case, I don't think there will be changes to this cap. Like the worst case is that we'll just not do it if you think it is not necessary. And I guess what remains is cap 67, which is the unified asset events. And there has been a lot of discussion about this cap, and I'm pretty sure there were changes to it recently. And these changes were basically ironing out some edge cases. Specifically, okay, we can like working backwards from the history. What we did update is that we completely removed from max steady from all the classic events. So for some context, originally cap 67 proposed for transfer events emitted by the classic operations is cap 67, and by Sorban token transfers starting from protocol 23. Initially, there was a proposal to allow multiplexing for the transfer source, but since it leads to a number of inconsistencies and is generally not something super widely used, basically it's like a transfer where you want to denote that some virtual uncustodial account has initiated it, even though like still need to sign for it. It's kind of a weird use case, and I guess the outcome of the discussion on all the edge cases this comes with was that let's not do this for a while until at least next protocol, and let's just focus on the minimum things that we definitely know is useful, which is to multiplex ID, and we know this is useful because this is how exchanges typically identify their users. So it's that representing non-custodial accounts, so they can attribute token deposits to their own user database. So this is one change. Another change is actually what makes this cap still not ready for the final approval, I guess, is change to how we emit information about the fee refunds. So again, from the previous discussions, the current status is that it'll emit two events called fee, and the first fee event is what we charge initially before applying the transaction. And the second event is also a fee event, but with a negative value, and it represents a refund. So now in Sorban, there is refundable portion of the resource fee. So whatever portion of this fee that hasn't been used will be funded after applying the transaction. And this is what we have in cap now. What we still haven't converged on is whether we want to add some additional attributes to these fee events that tell the consumer of the event when exactly did this charge appear, because fees are charged before all the transactions are applied, so it's like not a part of the typical transaction flow, and fee is refunded before protocol 23. It is refunded after the transaction is applied, and starting from protocol 23, the fee will be refunded after all the transactions are applied. So there is this annoying inconsistency with all the other events, because all the other events happen during transaction being applied. Fees happen before or sometimes after all the transactions are applied, and I guess the outcome is that we might alter the metrics there slightly to add some information on what is the timing of the fee event to kind of make this more obvious. But yeah, still not sure if we have converged on this finally. So this is something I guess we'll try to prioritize and finalize this cap. Yeah, it is. Yeah, I guess not nothing major is happening here, but there's lots of these small edge cases that keep coming up. So yeah, kind of it. So I guess that's the only cap that is still not fully finalized. And I hope this timing will be the last small thing that we kind of clarify. Yeah, that's pretty much it. That's right. Any questions from this cap or any other caps? But again, as I said, we for the other caps or no changes. I guess there are no questions. So I don't know. Shall we go to meetings then? Or anything else to discuss? I think everyone's quiet, so that's it.
Yeah, I was just curious if there was like any feedback on the restriction that were put on the memo from anybody, but like.
Yeah, I don't see any feedback. My concern generally is that this stuff may not be like super discoverable. My suspicion is that if we make some incorrect decisions in terms of event layout, we'll learn after we have launched CAP 67 when people start actually consuming the events and find out some use cases that are not covered. To be frank, at this point, I think like we should just converge on something that simply works. It's 95% of the cases, and yeah, if we find some issues after it has been launched, we can address them in the future protocols. Protocols. The good thing about meta events is that it's not even part of the protocol, so you can issue a quick fix. Some information is missing or not necessary, or it's not represents a value as it should. So it is fixable, and I think CAP 67 is in a reasonable state right now, and it's raising too much room for misinterpretation. So I mean, we are obviously open to the feedback, but yeah, as I said, objectively, like I feel like at this point, like we got in such edge cases that yeah, I'm not sure if it is clear enough for anyone who was even going to consume these events. I don't think it's clear enough for them that things are happening or not happening. Can see Lee's typing in. Lee, I've been talking a bit about CAP 69, the getter for the address executable. Yeah, for CAP 67, the timing of the fees, I don't think this has been finalized. We need to finalize this, I guess, outside of this meeting. I think you're almost there. We can just add the timing email to the transaction events. But yeah, we still need to make the respective update and post some discussion thread, I guess. So what I wanted to talk about is CAP 69, the getter, 69, the getter for the address executable. I know, Lee, that you had some comments on this and there was some amazing discussion. So maybe if you wanted to talk about this, like if you're concerned about it in general, you could go on the stage.
Yeah, I think I don't want to just rehash what we discussed about. I think I was just like a little bit fuzzy on it. Uh, second, I'm just trying to find the cut. Sorry, what was the number?
It's 69. Oh, sorry, 68.
No, that's
So,
the
sorry,
yeah,
yeah, no, it's
yeah,
68.
because we split it. We that's right. We
Yeah.
split the cap into two.
How's the discussion? So I guess I kind of like here is my point of view on this. Like I kind of understand some of the concerns about like the use cases for this that say bit not as well defined. But that said, just from the API standpoint, I don't have like what I'm looking for is if there are concerns for the API itself, like if someone thinks that it is not the information we should be exposing at all. Because if there are concerns like that, then that's totally valid. We could discuss them. But if you're like trying to understand like the nuances of the use cases, I like I feel like we can fulfill some of the use cases at least, and we can work on more advanced tools if necessary later.
Yeah, I think like the API that's proposed is very reasonable. I think it is very reasonable. I think it's the question is what you just highlighted in that is there a reason not to expose this information? And it reminds me a little bit of the when we were looking at what APIs to expose and what ones not to expose. One that we chose not to expose that other blockchains do and Ethereum does is the concept of a message.sender. So I think, if there was a proposal to add message.sender to Soroban, it would also look sort of similar to this one. It would look very reasonable. It sort of makes sense as a primitive that a contract would have access to, but we made an intentional decision not to include it in the original, Cat 46's, because we have seen the effect of it in other ecosystems where it can be used inappropriately, in a way that it's like a security issue, and it provided a view into who's calling you, as opposed to like what the auth framework that we've designed is like a better, safer way, that abstracts the concepts of like accounts and accounts and contracts. So yeah, I guess that's where I'm coming from. That's where my concerns are coming from. And when I read through the motivations in here, I think I understand the motivations now, but it doesn't really completely address those those use cases. So if you want to pin the exact implementations, yes, it does work for direct dependencies, but not for transitive dependencies. So as a primitive, it sounds like it will fit some use cases. It's unclear if it's completely solving those use cases to me. And then, yeah, I just have this concern as well of will this result in patterns of use that harm interoperability?
Yeah, I agree on the parents point. I'm not sure if transitive dependency is necessarily like these have, I think, two concerns that are kind of incompatible, right? Because like if we went down the pinning roads and the concern is that the pinning is not strong enough and we should also allow for transitive pinning, then we are actually going deeper into the whole of like no interoperability, because not only do you like pin the direct call, but you also want to pin something that happens in the like as an implementation detail of that call. Honestly, like
The harm interoperability piece. Sorry, I think there's like a few different. That's not so much about the pinning. It's more to do with making contracts aware of, say, the Stellar asset contract versus another token, and then writing behavior that
well,
is explicitly different for the two.
yeah, I mean, I kind of guess this concern, like for the Stellar asset contract specifically, say you can do this right now if you want to. You need to like do a bit more work can do that. So given that, like for the sec versus non-sec, like I kind of get the concern, but we cannot really hide it either. So I don't know. I feel like not.
Oh, you're saying you can do this today? You can already do this today
Yes.
because you can go and get the name,
Yes,
and you can encode the XDR and then verify if they match the
Yes.
same.
Yes,
Alright,
basically.
that's a good point.
Right. So basically, like here, the trade-off is not between like whether like this is possible or not. The trade-off is like if people want to do it, should say keep doing this in a hacky, less efficient way, and whether their use case is good or not, like they still may shoot themselves into it because they kind of messed up this external coding or something, versus providing something that at least they kind of know works. And yes, you can build something better out of it, but on the other hand, like there are different ways of kind of censoring which contracts can interact with your contract, and this is actually something that people have been requesting, and this is like how stuff like string key contract ADE hard coding might end up working, and people kind of keep coming up with this ideas of like, what if I want my contract to only interact with, for example, XLM or something. So I don't know, I feel like we're kind of past the point where we could make things truly abstract. So I gotta get this concern, but yeah, at this point I feel like for the most part we cannot do much about it. Or just there because you can get ID of any contract, so at least you can hard codes and contract IDs.
Yep. Okay, yeah, I don't have anything else to add to it. I'm not like opposed. I'm not like strongly opposed to it. They were just my concerns. So I get the benefits. Yeah, I think it looks good.
Thanks, sounds good. Yeah, I mean, yeah, I'll think a bit more about this. Like, and yeah, maybe double check with other folks. But yeah, honestly, like I feel, especially for something like transitive dependencies, like I think this actually strikes a reasonable balance because like you still can achieve that, but you need to make this explicit, and making this implicit sounds like a bit sketchy because technically you shouldn't have control over what other contracts are doing. So I don't know. Yeah. I guess that's kind of settles it more or less. Yeah, I'll think a bit more about this, but hope we should be more or less on the same page here, and should be good to go with this kind of. Yeah, right. I guess that should be truly for today. And there are no more concerns. Yeah. Thanks, everyone. See
Yeah, thank you.
you later in the next protocol meetings. Bye.